Congratulations, everybody. The surprise talk that you've opened up is about data federation and data lake. So it's impressive that you all found it. As was said, my name's Ben, and I'm going to talk to you about some new features that are coming to MongoDB Atlas that are going to really transform the way that you use the platform and satisfy a couple new workloads and potentially save you a lot of money. So to start, though, I actually want to step back and define what is analytics, right? And take kind of a standard dictionary definition, you'd probably see something along the lines of the examination of anything complex to understand its nature or determine its essential features. And for those of you familiar with MongoDB, you're probably thinking, MongoDB queries satisfy these exact type of workloads all the time, and that is true. But the reality is, for those of you who have tried to satisfy larger workloads, more complex workloads in the analytical space, you've probably had to make trade-offs inside of your cluster to satisfy those workloads. Maybe adding more indexes that aren't really solving for problems that your application has, or structuring your data in ways that isn't optimal for the app. So the features that I'm going to talk about today are really going to key into how you can avoid making those trade-offs and still get the functionality that you need and answer questions that are more analytical, scanning larger amounts of data without impacting your application or your workflow. So first, the agenda. The things that we're actually going to cover today are starting with some best practices around building applications on top of MongoDB. We're going to actually talk about microservices a little bit, and we're going to talk about data modeling. Then we're going to go into a little fictitious story about me building a business on top of MongoDB, where I choose to implement some of these best practices and the challenges that arise because of that. Then lastly, we're actually going to talk about how data federation and data lake can solve exactly these types of challenges. So best practices. So there are a lot of best practices that you can use when using MongoDB. The two that we're talking about are microservices and data modeling. They're really important to use when building on top of MongoDB because of the flexibility that we give you inside of the database. So first and foremost, microservices. I'm going to do kind of a quick review of the two different best practices here so that we're all on the same page. So microservices is an approach to building software that uses small, independent, and composable services that together form an application. And these services will communicate over APIs. They can impact the architecture of your application, and obviously they can also impact how your organization is set up. They're a really powerful abstraction, but they're not without costs. So imagine we're building a, music player service, right? And we have a presentation layer UI at the top, which is maybe a mobile app or a web app. We might have one service that is a music player, right? It plays the files for our service, lets people listen to their music. And the other might be a song catalog, has a list of all the songs that are available on the platform. And these two services are going to communicate over an API, and they're going to use APIs to communicate with the presentation layer. This, simply put, is a microservices approach to building an application. Now, most likely, you're not building any application based on top of two microservices. And so there's a lot more to it. And there's also a lot more to putting this pattern into practice with MongoDB. So I definitely recommend checking out a couple of the talks that are being given about microservices here, or looking at the documentation online, which actually covers putting this pattern into play. The second thing I want to cover, though, is data modeling. And so data modeling is really crucial to success with MongoDB because you have such flexibility when it comes to the structure of data that you put inside the database. And it can impact the performance and the scalability of your application. The three bullets I have here, there are three things that I keep in mind when it comes to modeling data. They're definitely not exhaustive, and we have actually a lot of great documentation about data modeling that I would definitely recommend taking a look at. But fundamentally, your data model should really serve your system and your application structure, right? If, for instance, you have customer object like we have here on the right, and often when you access it from inside your application, you're also presenting address alongside it, then great. By all means, embed address inside of your customer object. But if for some reason you often display them separately or using them independently, maybe embedding is not the right decision. The other thing that I like to keep in mind is not embedding unbounded nested structures. So like on the right here, we have a customer object with an orders array embedded inside of it. So we might be adding orders over time as this customer places more and more orders on our platform. This could hit our 16 megabyte document limit. It could cause other challenges when building an application. Generally speaking, not a good practice. Then lastly, I just like to keep in mind keeping documents as small as they can while still serving the core application's needs. And what I think this relates back to that's most important for this talk is often you don't want to store the state of the document within the document or something along those lines. So you don't want to kind of version the document inside of the document. You don't want to kind of keep those things together. And so with these two best practices covered, let's go ahead and kind of jump into the idea of building a business with them in mind. So this is the story of my business. I'm calling it Phase 1 New Beginnings. I am building a e-commerce platform. I'm going to connect buyers and sellers from all over the world. And I just feel like I have to mention this. I created this presentation before the keynote was created. So take it for what you will. But I'm connecting buyers and sellers from all over the world. And they are going to come to my platform. And buyers will have kind of the ability to buy things from all over the world. There'll be sellers accessing whole new marketplaces. Very innovative, completely transformational. And the first thing that I'm going to do is I'm going to build a storefront application. And let's say that I'm going to model my data with my sellers each having their own database. So I'll have a database for my sellers, and then maybe kind of collections for each piece of functionality that they're using inside of the app. Then each seller will get their own database. It's a good way to approach kind of a multi-tenant system, right? Each seller's data is kind of separated from others, and the app can have kind of a consistent interface into the database. That's great. So let's assume that business is going well. I have more and more customers coming on board, and that's great. And now they're starting to ask me for new services. The sellers have decided they'd like me to help them serve advertisements, or they want me to help with their shipping services. This is great. My application is really well suited to handle these use cases, and the database is really ready to scale with me. And that brings me to phase 2. I'm calling this the Great Expansion. And so for the Great Expansion, we're going to look into what the database might look like. So here we have one of my hottest sellers, Cookies Experts, and one of my less well-performing experts, Vegetable Pros. And they each have a users collection and an orders collection. And Atlas is really well suited to serve this app experience. I've scaled my cluster up and down as demand has come in. And I can even scale it horizontally if I want to. If maybe I need to shard, maybe Cookies Experts is located in the EU, and there's strict governance around cookie data. So all of these things are possible. And what's nice is if I decide to then put my ad service in another cluster, I can scale that independently. So maybe Storefront has more demand. It's been around longer, and ads is kind of still getting started. But I can store that separately, so that's great. And I can do the same thing for shipping services. So this is super convenient. My app is easily able to manage kind of the different connection strings to the different clusters. And everything can be scaled independently based on the load being put on the system. So super flexible, really convenient architecture. And that really brings me to phase 3. And I call this phase the Trough of Despair. And you're probably wondering, why is this the Trough of Despair? There is a graph that is up and to the right. There is an arrow, and there is a bank. And so these all suggest success is being found. And you would be right, but there is also data piling up. And as my business has grown, I've also started to receive maybe some new requests. Maybe investors are looking for more information about how the state of data is changing. Maybe I have some compliance or regulatory bodies inside of Germany that are concerned about Cookies Experts and the type of suites that they're providing. And all of this kind of concerns the question of getting a picture of my data across all of my infrastructure, which you just saw is kind of separated into different databases, but also maybe the fact that the data is changing over time. So the state of these collections is variable, And since I'm adhering to some of the best practices I suggested earlier, I'm not storing a lot of state inside of the documents themselves. So going back and referring to what something looked like on June 3rd is like a little challenging. Well, I've got great news, because that's exactly where data federation and data lake come in. They can make these challenges really melt away. So for example, with Atlas Data Federation, I can take my 3 clusters and create a federated database instance. I can then take a virtual database and set of virtual collections and map data from my storefront cluster into this virtual collection orders. And now when I query the virtual storefront database and the virtual collection orders, I'm getting data from both collections inside of my cluster. More so, I can keep mapping, I can keep building new virtual databases and connecting the source data in the underlying clusters all across my entire infrastructure. And there's 2 things that are really important to call out about this picture that we have here now, which is, sure, we're unioning data, which in some cases you can do within the database, but you should notice that we're actually unioning data from different clusters into a single federated database instance. And so while my application is probably ready and easily able to handle the fact that each one of these are a different cluster, maybe when it comes to providing access to this data to other parties inside of my organization, having a single connection string would be very helpful. And maybe it would be important to be able to tie my labels data to my users' data or to specific orders, right? So with Atlas Data Federation, you can take a pretty complex infrastructure that serves your application very well and reduce it and turn it into a much more simple and usable view of your data. In the last screen, we had 12 different collections that were reduced into 6. But if you had 18, 24, again, they would reduce back to 6, right? And again, they would all be accessible within 1 connection string. What's even more interesting, though, is that you can continue to use the services that you know and love inside of Atlas, like charts, like Compass and Shell. And maybe most interestingly, you can use our new Atlas SQL Dialect that you heard about in the keynote. I would definitely recommend going and taking a look at the Atlas SQL presentation being given later by Ryan Shipman. It's going to be really good. And there's just a lot of nuance about what the new Atlas SQL Dialect is giving you when it comes to flexibility of using SQL with a document model type data structure. And one of the coolest parts is that you can then connect tools like Alexi showed in the form of Tableau or Looker or other SQL native tools to your MongoDB data, potentially giving access to personas that don't have familiarity with MQL, maybe if you have an analyst team, et cetera, et cetera. So all of these things give you a really simple and usable view of the data. To sum up, with this federated database instance, inside of Atlas, you have a UI that lets you map sources inside of your clusters to virtual databases and collections. But you can also map cloud object storage, as you saw Wisdom do during the keynote. And you can even write data out. And so you can write data back to your cluster. You can write data across clusters from one cluster to another using a federated database instance. But you can also write data to Parquet files stored in S3, which if you saw the Coinbase talk earlier, you saw Shun talk about quite a bit. So a lot of power within the federated database instance. You can choose to not transform or move your data, or you can use federated database instances to move the data to where it needs to be. So also, just to quickly call out, for those of you familiar, this is a relaunch of our existing Atlas Data Lake product, orienting it more towards the places where it's finding fit with existing customers, and we're seeing a lot of success with it, and a few new bells and whistles that we're releasing along with it. But what's really important about that shift is it also opens up the name Data Lake, which is for one of the things I'm most excited about MongoDB World this year. And so one of the challenges we talked about earlier was the need to basically understand the state of data at different points in times in my cluster. And so if you imagine that Cookies Experts is doing very well, and from June 2nd to June 5th, the users collection has grown from 50 to 106. And you're keeping that collection lean so you don't have any unnecessary data, and you want to go back and look at kind of a previous state. Well, with Atlas Data Lake, you can create a data lake pipeline that takes data from your storefront cluster and copies it in to fully managed analytic a fully managed analytic storage tier. And so every time on a schedule of your choice, we will extract data from the cluster without impacting the cluster at all and land it in a new storage service that's based on top of cloud object storage with a new technical catalog that we call partition indexes, which give you improved performance over that data and still give you the benefit of a much cheaper cloud object storage solution. So just diving a bit deeper into the UI here, when you set up a data lake pipeline, you'll see a pipeline name, you'll choose a data source inside of your cluster, and you'll set a schedule. Then every time the schedule triggers, we will pull data out of a consistent view of your cluster as of a specific point in time and land it into a data set. And then once ingestion is done, you can easily jump over into data federation to query these data lake data sets just like you would any other source in your federated database instances. Finally, one of the things that's really cool that you saw in the presentation was the use of our new wildcard syntax. And so you can see in an example here, instead of needing to update your storage config every time a new data set is generated, you can have your federated database instance materialize those data sets as collection names as they become available. And so if you're distributing access to this federated database instance, it's really easy to give people the power to go ahead and query them directly as they become available. So, from my perspective, this is the fourth phase of my story, and we've reached salvation. With data federation, you have a way to unify data across clusters into virtual databases and collections. With data lake, you have a fully managed analytic storage tier with consistent cluster snapshots. And it really solves a lot of the challenges that our customers are constantly encountering when it comes to using MongoDB and the long tail of use cases that arrive building applications on top of it. So before we wrap up, I just want to quickly review some of the use cases that we have spoken to customers about and where we see this finding fit. So first and foremost, we see a lot of customers having interest with analytics and BI, getting a just-in-time view of your cluster data in a fully managed analytic-oriented storage service that is very cheap, has a totally different cost profile than your cluster, and is completely pay-per-usage. We see customers finding fit with ETL workloads, so extracting data from your cluster, landing it in Parquet files. And we actually see customers interested in using data lake data sets as the target for running those queries against, because your data lake data set gives you a consistent static view of data from your cluster that's not changing underfoot. And then lastly, we see customers just interested in data lake data sets from the perspective of time travel, right? Go back and look at what a collection looked like at a different point in time for development, troubleshooting, or for simply restoring a document that got lost. A lot of easy ways to make use of data lake data sets. So to wrap up here, a couple takeaways. We started off by just talking about some best practices to put in place when using MongoDB in the form of microservices and data modeling. We talked about the challenges that they introduce. And then finally, we went to solutions and salvation in the form of data lake and data federation. So now that we've reached salvation and our data is flowing with Atlas Data Lake and data federation, just a couple key callouts. I want to encourage everyone to take a look at our docs. They're all revamped for this new experience and for the new service that is Data Lake. And I would definitely suggest just going into the UI and trying out these services. They're extremely easy to get started with. You could probably get started in 5 clicks of a mouse. And they're either completely free or almost free to get started. So really cheap. So I would definitely just recommend going in, trying them out. You don't even need to read the docs. Why do I say that? But I would definitely recommend just getting in there, trying it out, and seeing what happens. And so with that, I will say thank you and open it up to questions.
Yes. How many storage tiers do y'all support?
Yeah. So in our core Atlas product, right, we have MongoDB clusters, which are also referred to as Atlas clusters. They have various tiers, right? Those have to do with kind of the level of compute that we have, the amount of storage you're able to access. This is a full new tier. And this new tier of storage is based on cloud object storage, similar to our online archive product. And I would say really we have kind of two tiers of storage, but there are kind of tiers within our cluster product, and now this kind of fully managed object storage tier.
So, but can you take advantage of Glacier,
Oh, yes. Great question. Yeah, so right now we don't offer any tiers within data lake storage. That's something we're interested in doing in the future. So if you have thoughts about that and what you would like to see, definitely be interested in hearing about it. Oh, and with that, I will call out, we have feedback.mongodb.com, which I would really recommend you go to, submit requests. I spend a lot of time there looking. We also have the community forums. I would recommend reaching out to me directly, all of those things. Question?
How do you define the schema at the virtualized layer?
So you don't have to define a schema at a virtualized layer. So just like with MongoDB, you can put a document into MongoDB. You don't need to define a schema. You can request it back. At the virtual layer, you're describing kind of maybe the schema of the overall database with collections and what the sources are, but you don't have to define a schema for the actual documents themselves.
How does it connect to the source data? Any impact on the front end?
Yeah, great question. So the data federation layer allows you to create a federated database instance. When you do that, you can connect it to AWS S3, you can connect it to Atlas clusters, you can connect it to these data lake data sets. AWS S3 has no concept, right, of kind of like contention in that sense, or none that they reveal. And data lake data sets also don't. But when it comes to an Atlas cluster, we give you more control over that. So you can set a read preference when connecting to have it only connect to a secondary, only connect to a read-only secondary, like an analytics node. So we give you a bunch of flexibility to ensure that the reads going through the federated database instance don't impact your operational load on the clusters. But if you don't set anything, then by default we use a read preference of nearest. And so it's a good thing to keep in mind depending on what your requirements are for freshness of data and consistency through that connection string. Definitely.
The demos I've seen so far seem to be more geared towards maybe descriptive analytics or that type of thing. What about ML and more advanced analytics?
Yeah, so I think it's an interesting question, and I think you definitely find me after because I'd be interested in just talking about it further. This is giving you a new target for your data to run queries on it, as you will, with MQL syntax through the provided drivers, and now through SQL and JDBC. The reality is that depending on the type of analytics you're doing, depending on the size and structure of your organization, maybe you need a warehouse, or maybe you need a different type of solution. Absolutely possible. The premise for our new data lake data sets are to kind of give this just-in-time version of your data that can be more readily accessed by the drivers that we support and the MongoDB query language that we support. And so fundamentally, if, for instance, the tool or platform or ML framework that you're using doesn't support connecting through MQL or a generic JDBC driver, it's possible this could be problematic from that perspective. But we're actually working with a lot of partners now to make ML tools and services more easily able to access MongoDB data. And there are a couple new and different things that I'd mention. The Python driver has very good support. But more importantly, we actually just released something a few months ago called PyMongo Arrow, which actually uses the Arrow interchange format so that you can get data that's stored in MongoDB into Arrow data frames, which are very readily consumable for kind of matrix type operations that you might be doing with ML. So we have a few things in that space. I think this is more just about kind of the storage of the data and how fast you can retrieve it. At the end of the day, for a lot of these ML type workloads, it needs to be pulled into a separate system to process. And so the question there at this point really becomes more about connectivity and doesn't exist. And we have the Spark connector, we have a lot of solutions in that space. But I'd be interested in talking about it further later. Any other questions?
All right.
Thank you very much.